Come on. And we're live. Damn it. Welcome in. I'm always trying to time these beginnings, man. Monday, noon-ish Central Time, 1-ish Eastern. What is it? 10-ish Pacific. Thank you so much for joining us today. I have an awesome guest, returning guest on my channel, Cory Steuben from Munro Live. He's been on the channel before. One of the biggest automotive experts, really, anywhere you can find on planet Earth. Him and his partners run Munro Live, the YouTube channel, and they also just launched a new podcast channel as well that I definitely want to let you guys know is out there. I'll have producer wife here bring it up when she has a chance. Cory, how you doing, man? Good to see you again.
I'm doing great. Just got back from Berlin on Saturday, back in the office on Monday.
Nice. Yep. Nice. Awesome.
Oh,
there it is. Go ahead. You want to plug it?
Yeah. So we wanted to do some long form content similar to this. So Eric has been working on landing some pretty high profile guests. Our first guest was the CEO of Polestar, and we're going to start to park our podcast there and do some of the short stuff on Munro Live, but just got started there. So a lot of content to come in the near future.
Awesome. Yeah, they're a brand new podcast with the Polestar CEO dropped this morning about 3 hours ago. I haven't had a chance to listen to it yet, but it's with Sandy and the CEO of Polestar. So that's bound to be a fascinating discussion. So definitely check it out. We'll make sure to drop links for that in the comment section below. But I know Cory just mentioned that he just returned back from a trip to Berlin to visit the Tesla Gigafactory. And apparently we're going to learn some cool stuff today. So Cory, I'll let you just take over a little bit of the intro and how it came about. Sort of how you guys ended up there, and maybe we'll start a discussion on what you saw.
Yeah, it was a little bit of a gray area how we even got invited to do a tour of Giga Berlin. So I think it was about a month and a half ago, I got an email from someone named Bernhard, I think Berndy, from the Austrian Tesla Club. And they said, hey, we're touring the Tesla factory on this date. We'd love for you and Sandy to come. And we're like, oh, this is great. Yeah, we'd love that. I talked to Sandy and he's like, yeah, let's do it. So we started looking at flights and things started coordinating pretty well. And we booked our flights. They added our names as part of the Austrian Tesla Club. Now, technically I own a Tesla because there's a Model S Plaid registered in my name, although it's tore down. It's registered my name. Sandy drives the Model 3. So we're Tesla owners. And we get official invites from Tesla. We had to fill out some forms. We got our QR codes. We fly to Germany. We get there. And then we kind of find out the people in Berlin weren't super thrilled when they needed English speaking guides and they realized it was Sandy and I. We actually got separated from the group. They separated us. And one person walked Sandy and I through away from the other 40 Austrian Tesla Cup people. But we got in. And I thought there was a decent chance we might get turned away. So Sandy and I were at the Cyber Rodeo in Texas. We were at Investor Day, and we just went to the Berlin factory. But now let's get into what we saw. So it was a full production day, a lot of forklift traffic. So when I was in Texas, I didn't notice a lot of forklift traffic. It seemed like a really light production day at Investor Day. There was almost nothing going on for Cyber Rodeo. But they were really pumping cars out. The stamping presses were running at full speed. All the furnaces were on for the 4 Giga casting machines. You could you could feel the heat from the furnaces. So they walked us through. It was called a wide aisle tour. So it wasn't like the private VIP tour that I think dignitaries would get. We had to stay in the main aisles, but there was a couple unique things Sandy and I noticed, particularly with some questions on build quality of the rear doors. So a lot of the Austrian Tesla owners, they were talking about this small gap. I don't know, I can't make a shape. It was like a small gap in the rear door. So there's 2 pieces of, I think, aluminum that come together. And they're like, why is this here? So we actually found the pieces and parts that had recently been welded together in the body line. And we actually stood there and looked at them. And that gap was there, and it was there. And we didn't know if it was a big issue. And then Sandy hypothesized that maybe it's there by design. Maybe it's this, that, and the other. And we happened to run into 2 Tesla employees in the airport that recognized Sandy. It happens all the time. And they were in body. And we asked them, we said, that tiny little gap, is it supposed to be there? And they said, no, no, no. They said, we're trying to get that fixed with stamping. And we ended up getting our answer there. So they're trying to improve it, but it doesn't affect sealing. It doesn't affect NVH. It doesn't affect anything. It's called a B surface. You only see it when you open the front door and you're like getting in the car. And once you close the door, it's then hidden again. I can't explain it very well without seeing it, but it's a gap that's not there on the Texas or Austin or Fremont built Model Ys. So they're still working out some of the production kinks. And I did notice in the body line, there was someone with a flat file filing the corner off of a lift gate. And I looked at Sandy, I said, yeah, you can tell they're still ramping if they still have files out, filing the corner off of but these aren't bad things. I'm not like disparaging what I saw, but those two things really stuck out. But Sandy and we have really trained eyes. So we're looking for anything that sticks out. And because there's some other YouTube channel that got a hold of the 4th generation drive unit with the new inverter and the integrated oil filter. So I think your producer has pull that up.
Yeah, producer wife, pull up the picture in Discord that I sent you. The other one,
no.
the Discord DM. Yeah, that one's for later. Teaser. Go ahead. Maybe give us a little bit of a background while she pulls it up here. Yeah.
So they used to have the screw-on oil filter for the gear oil of the drive unit, and essentially it was not needed. It's not serviceable. So they were using a serviceable, essentially it looked like an oil filter. They've eliminated that. And this is a screenshot from that YouTube channel. I forgot the name of it, but thank you for the screenshot. I think it's Engineering X or something. I maybe missed that. So when I saw the decking station go up with the 2 drive units, the battery get decked to the bodies, I could see under the car and I could see exactly this. And I lost my mind. I looked at Sandy. I said, all these Giga Berlin, all of them, every one, we're getting the new rear drive unit. Unless for some reason they've updated this on some without the updated inverter and stator. Now, the big benefit is this drive unit is supposed to have more power and cost way less. So this just double and triples. It triples. It doubled down. It's a double down on the lead that Tesla already had. So they already were hugely profitable with the old powertrain. And then this one is a huge leap forward in cost reduction and an increase in power. So that just tells you that the continued level of improvement never ceases at Tesla. And I think they might want to be quiet about this, because I'd hate for people to be ordering a Model 3 and a Model Y and getting under the vehicle and understanding that maybe you have an old drive unit. So they're not being, I think, real vocal about which vehicles are getting this, but it's only a matter of time before Munro gets a hold of this 4th generation drive unit, does a teardown. So this was the biggest thing I saw, and that's about it. So.
It's pretty amazing that this is what happens when you have a bunch of engineers walking the line. Is like the tiniest little thing when the car's going up, you're like, holy crap, that's so is this getting us closer to what Tesla was sort of outlining on their investor day when they said, hey, we're kind of building this drivetrain that's going to bring the cost down to sub $1,000 or something. Yeah. This is sort of an iteration towards that.
So I do not think that what they call the 4th generation drive unit, I think there's some phrase for it. I don't think this is that super low cost drive unit, because this most likely still has rare earth elements in the magnets. And they wanted to get to a point where they have hairpin for the stator. So those are the bars in the stator. And then essentially iron oxide. I think they're iron oxide magnets, essentially just regular magnets, like magnets that you have on your fridge are just iron based. They're not expensive. So if they can get to the point where you have the hairpin winding for the stator, the iron in the magnets, and then a low amount of silicon carbide in the inverter chips, and I think they mentioned 75% reduction in Investor
Hmm.
Day.
Hmm.
Those are your big cost drivers right there. The amount of copper, and then the amount of rare earth, and the amount of silicon carbide. You reduce those, the rest of the components in the drivetrain are cheap. You're talking aluminum, plastic, iron, steel for like the gears, the bearings, and some of the plastic stuff to divert oil and whatnot.
Hmm.
And I think this is an improvement of their current powertrain, but not the next gen.
Gotcha. But it's still a step towards lower costs. If you were, I mean, this is probably way too early. So we're kind of speculating. I mean, I take your word for it because you guys are obviously very well versed in this stuff. But it does seem like an improvement like this going into the line is going to help bringing costs down. Is it also going to help them sort of create more units? How is it going to impact their ability to produce more units, or is it sort of doesn't really matter in that case?
Yeah, I think the biggest benefit to producing more units would be the fact that if they've reduced the number of chips on the circuit board, if they've reduced the amount of fasteners, the amount of manufacturing operations to build the actual unit, it lowers your risk for disruptions in supply chain or inflationary factors. So
Mm.
at Munro, we own the domain lean design, and we are always trying to achieve the same functional objective with the least amount of cost, weight, and parts. So if you look at some of the first drive units we saw from Tesla for the Model S and X, they were huge, they were expensive, they were complicated. Then the Model 3 came out, and it was a huge reduction in cost and weight, and the power density increased dramatically. And then we've seen fine refinements and refinements and refinements because we have a Model 3 drive unit, we have a 2020 Model Y drive unit, and we have a 2022 Model Y drive unit, and now this. And they've continued to refine the circuit board and the inverter, the manufacturing processes. And then this fourth generation, they call it the fourth gen, that's the biggest step. We actually see massive change in the layout of the inverter. It goes to a rectangle. It's like about that big instead
Mhm.
of that weird shape that kind of looks like the United States that kind of fits in the
Yeah.
existing package. So they've gone to a more manufacturable rectangle circuit board instead of that wild odd shape that used to fit in the exact form factor of the drive unit.
Gotcha. And then, so if you think about the cadence of Tesla sort of coming out with this change on its drive unit, I know, with my sort of layman knowledge, if you're thinking about say a traditional automaker, when they're building their sort of gas engines and their drivetrains, I'm assuming they want to keep something like that in production, like a specific way that they're building the engine for as long as humanly possible without any sort of changes so that they can maximize the supply chain benefits and all that stuff, right? And it seems like Tesla's not afraid to sort of move on even on their more, say, complex or vital parts of their cars as quickly as humanly possible to get as many iterations out. Are you seeing a sort of acceleration in drivetrain development versus gas, gas engine development from legacy automakers compared? Is it going to enable them to move any faster? What are you
Um,
seeing? Yeah.
so with internal combustion engine development, there was intense refinement over the past 2 decades, particularly with emission systems and valve train systems.
Hmm.
So and what I mean by that is uh, you had wild EGR systems and crazy valve trains being developed late into the 2010s, 2015s. Like Fiat Chrysler developed this thing called multi-air. It was crazy how it controlled the valves. BMW and Honda always had their VVTs, which were really crazy. So and the reason I talk about that is the amount of complexity to solve an emissions problem on an internal combustion engines was really kind of amazing, but they were trying to solve a problem that would always exist. And I want to give credit where credit's due. The emissions that came out of vehicles in the 50s, 60s, and 70s was horrendous. And I saw some statistic that like they pollute 99% less. That we've eliminated 99%
Wild.
of the emissions with catalytic converters and and all the EGR systems and diesel with the urea. And all these engineers for 50 years used all their brain power to try and solve a problem that should not exist. And Elon said that when he was being interviewed by Everyday Astronaut. Engineers will spend their whole careers solving problems that shouldn't exist. And that problem is you're using the wrong fuel to move a vehicle. So now that we have electric vehicles, you're seeing a much faster pace change in some of the finer refinements, but electric motors have been around for like hundreds of years. I think Sandy always talks about there's some crude version of an electric motor from hundreds of years ago. But electric motors, there's a famous painting by an artist in Detroit who did this whole mural, and it's in the DAC, not the DAC, the Detroit Institute of Arts, DIA. It's a massive mural. I don't know what it's called, but it's of all these factory workers, and they're building engines, and there's V8 engine blocks going along. And I pointed this out to somebody. I said, look what's running those CNC machines. And if you look up
an electric motor,
electric motors. And the painting is depicting like early Ford days. I said, huge electric motors, probably 50, 100 horsepower, are spinning all these machines.
That's hilarious.
And so it's like when you have a constant power source, that was really what needed to be solved, was gravimetric and volumetric energy density to make an automobile viable. But electric motors have always existed. And we tore down a bunch of refrigerators, and we had the compressors, and you pull out the stator, and it's about the size of a softball, and you set it on the table, and you set a stator from a Model 3 right next to it. They look identical. The way the wires are wound, the laminate stacks. So when you open your fridge and get a gallon of milk and you hear your compressor kick on, that little electric motor is essentially identical to what's in a Tesla running around right now. So the amount to gain is much less. So with internal combustion engine vehicles, there was so much left to gain for efficiency over the years. And then the refinement got really small in the later years because everything had been squeezed out of it. And electric motors have already been heavily developed over decades and decades. And really, if you look at, we once had he was like a magnet expert come in. I forget his name. It was something simple like James Ball, or it was like some, I'm so bad with names. I should have been more prepared.
Me too.
He came in and he talked to Sandy and I for like 2 hours on the most ideal configuration of magnets. And there's a massive amount of study that's been done on it. And essentially, early in the days, General Motors had patented this ideal arrangement, geometric arrangement of magnets where they were slightly curved and parabolic. And then you had 3 sets of them and they were separate. Extremely difficult to manufacture because you're manufacturing them at a curve and all this stuff. And you see some OEMs use that configuration, but they're always using the low-cost magnets because in order to produce the high-end rare earth element magnets, you don't want to have the scrap rate. So that's why if you ever seen a rotor and you have the magnets, they're just at an angle. They're actually they're like a V. That's actually a compromise. There is an ideal magnetic field array that has been like investigated for years. The point I'm saying is a lot of this study and this work has been done 20, 30 years ago. It just comes down to how much cost do you want to put into your electric motor in a vehicle for the value it's going to get. And a lot of times you'll see OEMs make a compromise. They'll choose magnets that are flat and straight and rectangular and at slightly less than ideal configuration because you maybe get 3% or 2% less efficiency, but the cost drops by $100 a motor. And so it's a long-winded answer to your question.
That's completely fine.
I think the technology and the expertise is out there. It's just how much how much profit is an OEM willing to give up for increased MPGE when deploying technology or stuff that used to be patented into a powertrain that'll move the vehicle along?
Gotcha. Okay. So that's actually, I mean, I'm glad you went into detail because it really helps, I think, me really think about the context of drivetrain changes. So if I'm thinking about an entire drivetrain unit, sort of riffing on this idea, like the drivetrain is a combination of the motor and the battery, let's say, right? So it's like those two things
Yeah,
is what actually, go ahead.
I look at the drive unit as
Hmm.
the motor, the gearbox, and the inverter.
Okay.
And some people group the battery in there, but the battery, I more relate that to like engine systems. So
Okay.
back when you're in an internal combustion engine vehicle, you had air induction, exhaust, and fuel as engine systems, but you no longer have exhaust and air inductions, but you have fuel, which your battery stores the energy, right? So
Right.
I consider the battery part of fuel systems for an electric
Yeah.
vehicle,
Yeah.
for better or for worse. But powertrain, in my mind, was always engine transmission. Drivetrain was for an internal combustion engine vehicle was transfer case or PTU. So like for an all-wheel drive vehicle, you have a transfer case or PTU,
Hmm.
rear and front differential. So drivetrain is more of your driveline components.
Got it.
Powertrain is engine transmission. And I look at the battery as fuel system. So I think you just said powertrain and you group the battery in there. That's my personal way that I group it together.
Okay.
I look at the battery as a storage device.
Got it. Okay. No, that's perfect. No, so I guess that where I was trying to go with it is it does sound like if I'm thinking about as these automakers, Tesla, everybody, all the legacy automakers are sort of continuing on this decade from the development standpoint. What was very fascinating to hear from you is that the drivetrain, the motors, the electric motors themselves have been sort of solved for a while, like optimally solved. And the way you described it is like, well, it's all about what is your sort of equation that you want to do in performance versus cost. And if you want maximum performance, you're going to have to pony up for rare earth metals or specific configurations that's going to add cost to your system, especially in our current state where maybe we haven't built out the entire supply chain for these things. But there's an equation you have to do. But it still sounds like to me by far most of the cost benefits are in the battery system. If we're like thinking about that entire end-to-end drivetrain and everything else with the motor with the battery included, the battery still holds most of the potential innovation that could be discovered from the perspective of creating that optimal battery. We know what the optimal motor looks like, but we don't know what the optimal battery looks like yet. Is that a fair
Correct.
representation?
Yes.
Okay.
If I had to like gauge, I'd say motors are like 97% refined as refinement can be.
Got it.
Batteries, I couldn't even give you a number. I'd say maybe 60 or 65% as refined as we as a human race can get battery technology. There's so
Mm.
many things unturned, so many stones unturned. So Sandy and I have been traveling to different battery suppliers. We get invited, and we were just at a company called Amprius, and they have this wild silicon anode technology. They went through all of how they use these like nanotubes, and then they coat the nanotubes with this semi-porous silicon so that it can like soak up the lithium ions without cracking. And they like walk through it, and they have the batteries in production, and they're flying around the world in an Airbus little plane. And I mean, they were making them. I was staring at them, and they're at about 504 watt hours per kilogram, which is almost double a Tesla battery. I think a Tesla batteries, some of the best ones are 265 to 280
Oh,
watt hours per kilogram. What that means is if you can double the gravimetric energy density, you can shrink the battery by half. Then essentially you need half as much volume or half as much mass of battery to get the same range, or you can double the range with the same weight.
mm-hmm. Mm-hmm.
And that's why the holy grail for batteries would be getting in that 600 to 700 watt hours per kilogram. And it is possible, I think, using wildly exotic materials. So these nanotube silicon anodes plus a laser cut out titanium substrate for the cathode, which we saw at a company called SES in Boston. So there's all these companies are working on these super expensive, crazy solutions. But then again, cost per kilowatt hour, you're looking at $1,000 per kilowatt hour for these wild technologies. So you'll first see these types of batteries deployed in VTOLs, planes, race cars, something where you will pay. If you'll pay essentially $900 more per kilowatt hour to get a 50% weight savings on the battery pack. So who's going to pay that? Only airplanes, VTOLs, helicopters, aerospace, NASA, SpaceX, and maybe F1. If you need a little battery in your F1 and you can lose a kilogram for $1,000, sign me up. So the batteries are like the wild, wild west moving forward. And eventually you'll see this technology be deployed. It'll be deployed in these higher end marketplaces. And then someone will figure out a way to bring that cost down.
Scale.
But I think you're 5 years or decades away. And that's why if you look at the 4680, I think the 4680 is more of an economy cell. By economy cell, I mean, they're trying to make it as cheap as possible without any real exotic solid state technology. They're taking the current manufacturing methods, turn it into a dry process to eliminate all that solvent. There's a big solvent oven process and water oven process. So you eliminate the manufacturing costs. If Tesla stamps their own cans, rolls their own jelly rolls, assembles it themselves, they've now cut out a supplier, which is another 20, 30% markup. Now they can get the cost of the kilowatt hour down probably $70, $65 per kilowatt hour. They make a Cybetruck viable, total manufacturing costs, I think between 40 and 50,000. So I think that was a question you asked me, I think a year ago, maybe half a year ago.
Yeah, last time we sat down.
Yeah. I think you said that Tesla said they want to manufacture the Cybertruck for 30 to 40,000. I said, no way. I said more like 40 to 60. I think it's possible from 40 to $50,000. That's for like a medium range version. So not like the huge range version with dual motor in front, motor in rear, not a quad, not a tri-motor. And they can only get there because of the huge giga castings in the front and the giga castings in the rear, and their huge advantage in battery costs with the 4680.
Yeah, that's fascinating stuff, and definitely Cybertruck is something I want to pick your brain on a bunch because I know we have that picture that you really want to deep dive. I think the thing that's very interesting as you're talking is it does seem like we're now beginning to enter in earnest sort of this age that people like Elon Musk and others have constantly talked about, which is we're trying to get electric vehicles to be cost parity or cheaper than its competing, say, gas car. And it sounds like we're finally starting to really enter that age from an automotive perspective. I know, Tesla has been reducing prices this year quite a bit. At the beginning of the year, they did that massive drop. It's been going up and down. They had their earnings released last week, and there was a lot of hoopla around, oh my God, you should be marketing on advertising. You shouldn't be dropping prices as much as you do. But that's besides the point. I think what's really starting to come to mind for me that's a little bit more clear is that it's Tesla's strategy specifically, or any automaker strategy moving forward around electric vehicles. It seems like they have to figure out how to get the cost of these vehicles as cheap as humanly possible, as quickly as humanly possible, for them to really be adopted by the mainstream. But we're actually seeing that happen in real time. And so all these investments like the 4680, all these investments like the front and rear casting, you have the rear motor that you guys discovered in Berlin, which is another one. It seems like it's finally coming to fruition, or when the early stages of that. How much would you say if you're trying to compare, if we're talking specifically about the battery itself, and for a company like Tesla as an example, how much of their upcoming costs do you think are going to be driven by scaling the battery as much as possible versus trying to refine the chemistry to get the cost of the raw materials as low as possible? Like, how would you, and if this is proprietary information, you don't have to say it, but like, which one do you think is a bigger bucket, the chemicals or the scale? Like, where are most of the cost savings at for the next 5 to 10 years?
Yeah, I think the cost of the raw materials is really out of the control of most OEMs. So if lithium skyrockets, that's going to negatively impact all OEMs. Or if cobalt or some of the rare earth elements start to become even more scarce, you could have some geographies that have a monopoly on it, like Africa or China on some of the rare earth. So I think a wise move for an OEM is to eliminate the dependency on the critical rare elements that could be controlled by one entity. And that all those elements are being avoided by Tesla in their Master Plan 3 with their low-cost car. So they said no rare earth in the magnets, and then they could do LFP batteries, lithium iron phosphate. So there's lithium and there's iron everywhere, and phosphate is what I think, yeah, that's everywhere as well. So then the cans themselves are steel, plastic is everywhere. So aluminum is everywhere for the giga castings, and then the silicon carbide chips. So you could have some chip shortage. So reducing the dependency down to 25% from, reducing 75% of the usage of that. You really want silicon carbide for your inverter for efficiency. You don't want to use silicon. And there's emerging technology called gallium nitride, which could be in the next 3 to 5 years, something you see for even more efficiency, particularly at high voltages. So to kind of answer your question is the minerals and the elements, you can make decisions as an organization to eliminate these from your vehicle. But once again, it affects the functional objectives of the vehicle, meaning if you use lithium iron phosphate, the gravimetric and volumetric density is not as good as NCMA. So that means you need a bigger battery that weighs more. So then everything else you do needs to be even better. The car needs to be lighter. It has to be more efficient. So then you have the 48-volt low voltage system to be even more efficient and lighter. So if you want to make these decisions to help you from a cost or sourcing perspective, you have to be excellent when it comes to everything else. The level of integration of your thermal system, the efficiency of your low voltage system, the routing of everything, how you control the operations of the vehicles through software. Every decision is ultra valuable. And oftentimes people ask me, they're like, well, why was the Jaguar I-Pace MPGE so bad? And my answer is death by 1,000 bad decisions. And they're all small bad decisions. When it comes to how you source thermal system components, if you buy 10 valves and 5 pumps from suppliers and you have to mount them all over your car, now you have brackets and you have fasteners. Then you have to route the hoses between all the valves and pumps. Every inch you have extra fluid. Every bend is more resistance. And then you have 100 bends, your pump has to grow. When your pump grows, your pump's heavier. It draws more wattage, and it draws more energy from the vehicle. So when you see these EVs, these early ones that had MPGEs under 100 and Teslas were 115 to 130, it's never one decision. It's like 1,000 tiny bad decisions, and you got to get all those 1,000 tiny bad decisions right. You have to make 1,000 good decisions to eliminate all these parts, which will enable Tesla to then choose a lower cost battery and then step down from 130 mpg to like 110 mpge and still be as good, if not better, than the other OEMs. Because if Tesla improves all these tiny 1,000 decisions and they use a really high-end, nice battery chemistry, now their mpge will be as high as someone like Lucid. Now, Lucid, you can look at Lucid. They have an amazing powertrain. We have one. We're tearing it down. We're analyzing it. And that report will be for sale in 4 days. So if you're out there and you're watching and you want to know everything about the Lucid powertrain, we got it. But that has an amazing power density. So there's other OEMs that are doing great things, but they're selling the vehicle for $120,000 to $170,000. So you're getting a lot more, but you're paying for it. And they have a large battery and a really efficient vehicle and powertrain. So they have, I think, one of the best MPGEs. But once again, the chemistry they're using and all the decisions they're making, they're high-end decisions. So it's like a tug of war between functional objectives, meaning range and performance, and then value and cost. And it's always been this way. If you bought a Ford Focus with a 4-cylinder and you try and merge on the interstate, it's slow, and when you're driving, the wind noise is horrible and you're like, whatever. But if you buy a Lincoln Navigator from Ford Motor Company, it's dead quiet. You have an 18-way seat. It has a 500 horsepower engine. It's amazing. And you get what you pay for. It's so many people want to group all EVs in the same bucket. EVs must be cheap. No, a high performance, all-wheel drive, super fast EV is going to be $100,000. And if you want a cheap EV, it's going to be slow. It's going to be slow. It'll have 180 horsepower. It'll be rear-wheel drive or front-wheel drive. The battery will be small. It'll have uninspiring chemistry. The interior will be Spartan with very little buttons and whatever. And it's going to be cheap. The user experience is going to be degraded. And that's what I think a lot of people don't realize, how much value you get for a Tesla. So from $43,000 to $65,000, you get an incredible value. The vehicle does a lot. And the one thing that people forget is the FSD feature is wild, and you can activate it at any price range. And they sell the vehicle with that hardware no matter what. This is like a really common conversation I have with people in industry is, what is an EV and what's the right value proposition? And those decisions are tough for these large historical OEMs, because they're so used to playing with higher profit margins, because internal combustion engine vehicles are cheaper to manufacture, because you don't have a $10,000 to $20,000 hunk of money under the car called a battery.
Yeah. A lot of great info there. I think what's most interesting to me about this whole discussion is that it does seem like, when I talk to people about where the auto industry is going, there is this sort of almost a lot of folks assumes like, well, Ford and GM and these guys, great companies that they may be, they'll just figure it out. They'll just add the battery, they'll add the drivetrain, and they'll just move forward, and that's it. It's not that different from say that the gas engine and everything else. They're masters at building cars. It's just a different drivetrain. And I commonly have these conversations with folks that are following the Tesla story closely. That might not be as, say, bought on the whole, well, Tesla's doing it so differently. They're just a car company. It's just like everybody else. And I think the way you framed sort of the battery equation is going to dictate how the rest of the car should be built around the battery is something that sounds quite I hate to use an Elon Musk word, but profound. He loves to throw that word around a lot, but it does sound very profound, because it does very much impact the value proposition you bring forward. And it seems, if I think about Tesla specifically, about their upcoming, say, compact car, which, there's speculation on how much this thing's going to cost, what it's going to look like, so on and so forth. But you pair that with all the price decreases they've done lately, it seems like they are starting to reach a point where they could conceivably, there could be a car that's offered out for the public to purchase that is going to be somewhat affordable. So let's call this compact car somewhere between $20,000 to $30,000, maybe a little bit more. But it's going to offer performance that's significantly better than, say, its gas car equivalent at those price ranges. Not because of anything crazy they're doing, but because the electric drivetrain itself offers so many benefits over a gas or powertrain, whatever you want to call it, that sort of entire system offers so much versus its gas equivalent. And I'm wondering how, it seems like that's not well understood yet by the public, that there could be a $30,000 EV from whoever, it doesn't matter who it is, that it's just going to perform way better than your gas car from a performance perspective, and it's going to cost way less to run over time, and it's because of every single thing you just described. And I wonder just how much automakers are going to be able to capitalize on that in the next 5 to 10 years, because they're going to have to do so profitably. Otherwise, they're going to be in trouble. Are you seeing signs from legacy automakers that they're really understanding this sort of dynamic that's starting to appear? And do you think they are well positioned to be able to take advantage of the lower end of the market? How do you think about that equation?
Well, the first thing that comes to mind to me is the Bolt, Chevy Bolt. It's already 25 to 32,000, but it's so uninspiring when you drive it. Have you driven it?
No, I've seen it a few times, but I haven't never driven it.
It's small. It's compact, 4 doors, and the price point's already there, and it's selling a little better now. But I think in the past 7 or 8 years, I think it came out in 2016, maybe 15, maybe 17. I think they've only sold a total of maybe a couple 100,000.
I think you're right.
And Tesla sells more Model Ys than that, I think, in a quarter.
That's correct.
Yeah. So why is that? And if you want to get to the root of like, why do people choose to buy a car? It transcends beyond the nameplate. And oftentimes the legacy OEMs relied on long histories. Like some people, their families were always Ford families or GM families. And I drive a GM product, and my last 3 products have been GM products. And my parents own GM products. So why do I buy GM products? I don't know. But do I drive a GM EV? No, I do not. Did I order a Lyric and a Hummer and a Silverado? Yes, technically for the company, but do I have them? No. So I look at the Bolt as a test case for if an OEM puts a vehicle out in that price range, like everybody's focused on when will Tesla make a vehicle in that price range, not when will someone, because the vehicle exists, I think. But the value you get, if you buy the low end version of that, and the range doesn't match the expectation of what people want. So I think Tesla will enter that market with a much higher value proposition, and every single vehicle will have the hardware for FSD, for full self-driving, which the GM products do not. And they'll have more of the intrinsic EV value and less of a carryover vestigial OEM feel. So instead of getting in and pressing the start button, and having all the same buttons, it'll be a vehicle people want to own. And I think that Tesla will actually hit a home run in that space, and it'll be sold out for years and years and years. And the charging infrastructure and the range will be far superior. And I had one of my engineers do some napkin math, and I know napkin math. So I told him, I said, Antonio, I want you to do the math. I said, take a long range Model 3 with a long range Model Y rear wheel drive, or Model 3, whichever one, with the, no, not the long range, standard range with the LFP batteries. I said, what does that get for a range? And it was like 220 or something. And I said, I want you to do the math, parametric math. I want you to calculate the rolling resistance if it was smaller. I want you to calculate the aerodynamic performance if it was a little bit narrower and smaller. I want you to then factor in 53 kilowatt hours for the battery, because that was in the white paper. I don't know if you saw that.
Yep.
So I said, do the math as if it has a 53 kilowatt hour battery. And he did the math. And I said, I want you to factor in the efficiency gain of the 48 volt system and this, that, and the other. It was all this Excel sheet. And I'm predicting like a 254.3, somewhere 254.
We're holding you to the decimal, Cory. You better get this right.
miles of range for 53 kilowatt hours in a compact Tesla of that size. That's just if they do the bare minimum. And I think that's our minimum. So it'll be a minimum of 254 and change miles of range for that compact vehicle. And then you can have a higher end vehicle instead of being 53 that's for like the $25,000 version.
Mm-hmm.
And then maybe they might have a $35,000 version that gets a 75 kilowatt hour battery. Now you'll have 300 miles of range, so that'll be the standard range. So I think the standard range will be about 34 miles more based on all the efficiencies you gain of the vehicle being smaller and all the improvements, hardware 4 or driveline 4. So I should have brought my math there. I know people are going to be like, come on, Cory. Yeah.
But you mentioned, so you said that's going to be the 25,000. Like, again, so just FYI for everybody that's watching this is all speculation. We have, we're just kind of throwing numbers around. Cory is brilliant at this stuff, but let's make sure that we know that it's speculation. So we're not saying any of this is going to be in stone, but I think I'm curious to see how close we're going to get. But it does sound like, so 254 miles in a compact sort of form factor, and 53 kilowatt hour range or battery size. Is this at $25,000 a car that Tesla can make money on? So are they making money at 25,000?
Yeah. So this is the strength of Munro. We have a team of essentially 100 people, and we do cost analysis of everything. So I have a fully costed bill of material of a Model 3, a Model Y from Texas. So I already know with a tremendous amount of detail what a vehicle should cost. We do should costing, and companies pay hundreds of thousands of dollars for these reports. So if I look at where the cost resides in a vehicle, the largest is powertrain and the motors. So the battery, the energy storage, and then the drive units. So with the hardware, with the 4th gen drive unit, and if you go to LFP batteries and you only need 53 kilowatt hours, we can already calculate the cost savings there. And then you do 1 drive unit instead of 2, and it's rear wheel drive instead of all wheel drive. So that's like a $5,000 savings just going to rear wheel drive and having 1 drive unit instead of having 2 of the current units. And then the battery costs drop by about 35%, which is another roughly $2,500 to $3,500, just the battery cost. This isn't the pack and all the high voltage electronics. If somebody's out there trying to do backwards math, I'm leaving a lot out there. So just those major decisions, and then the reduction in cost because of the size of the vehicle, there's a lot of quick calculations we can do. That's pulling the manufacturing costs down below 25,000 already. Then it's going to take refinement in the manufacturing process with how the vehicle's assembled to get that last 20 or 30% savings. And I think Elon in the investor day said he's going to get like a third of it in like the design of the vehicle, a third of it in the manufacturing, and then a third of it somewhere else. I forgot. But the manufacturing costs, they don't make up a large percentage of the bill of material costs. So if you can pull out manufacturing costs, you don't get as much bang for your buck as reducing the bill of material of like using less batteries or 1 motor instead of 2.
Got it. So it does sound like, just mathematically speaking, just given what you know, so somewhere between $25,000 to $30,000 start price for this compact Tesla seems to be a very realistic target for Tesla to hit from a should cost perspective. And I think if there's one thing Tesla has shown it does seem like they are pretty good at getting as close as possible to that should cost because of how they tackle supply chain and raw materials and manufacturing expertise and all that good stuff, and how many fasteners they use and how lean they get with their design. So it does, and so let me ask you this: does that include the hardware for FSD as well in that sort of when you're thinking about it? Okay.
Yep.
So and they'll be able to turn on. Okay. So it's over. It's what you're telling me. Sorry.
Yeah.
I shouldn't say that.
Well,
Yeah,
now don't kid yourself.
yeah,
There's a lot of big players
yeah.
out there that are working tirelessly
Of
and
course.
innovating at a much faster pace than I think the past decade has indicated. So
Yeah.
there are other OEMs that do better in many places than Tesla. So uh, particularly like that Lucid motor we have, the way that the stator is assembled is just mind blowing. The gearbox on that is incredible. The
Mhm.
energy density uh, per unit volume, or the power density, sorry, not energy density. The power density per unit volume is out of this world. But is that necessary? No. But if you want a super high performance 1,000 horsepower vehicle and you want to pack 4 of those motors in a vehicle, it actually is kind of necessary from a packaging perspective. So it
Mhm.
depends on what your functional objective is. So I'm getting all the way back to that functional objective word. What do you want to do? And how fast do you want to go? And how far do you want to go? Those are the key drivers that start to lay out the monuments of how you want to operate as an OEM.
Yeah. Do you think there's room for multiple mass market manufacturers in this sort of new EV age? You know, given that scale and sort of maximizing that equation of sort of cost to performance, you know, equation that you have going on there, really focusing on manufacturing expertise. And given that, you know, you know, it's up for debate if a player like Tesla is going to be able to achieve that 20 million vehicles per, you know, per year by 2030 number. I mean, do you think there is room for what used to be a Toyota, or currently is a Toyota, GM, Honda, Ford sort of multi-million units per year, and the biggest player gets maybe 10% of the market share? Do you think that's still alive and well in this EV age in the next 5 to 10 years, given how Tesla's playing in the field, or do you think that's going away? How do you think about that?
Um, you've watched General Motors since the 50s. I think they had 50% market share in like 1950 or 60. And it
Mhm.
slowly slipped all the way down to like 17%. And you've seen Ford be relatively stable. Chrysler and Fiat Chrysler grew. Toyota grew, and they took over a huge swath of the American market. And now you look at China, that's a whole nother monster where it's getting much more difficult for American companies to even play there, or European companies, which, like VW is really the large European player, and Stellantis. So I guess to answer your question is, your question was more about, do you see there being parity? We have multiple OEMs at the million, 2 million, 3
Yeah.
million, 5 million cars. Oh yeah.
Yep.
In order to satisfy global demand, uh, you can't have a monopoly. And I think it would be illegal. You get antitrust lawsuits if there was only one car company in the United States.
Hmm.
Like, you just can't. The monopoly has to be broken up. So competition is good, because if you don't have competition, then what you have is like Russia, where in the Cold War, where there was no development, the cars were garbage because, what was the motivation to innovate,
Yep.
you know? So I guess Tesla's goal of 20 million is ambitious, but I'd rather set a super ambitious goal and miss and still end up as the market share leader of the world, because that wouldn't be so bad,
Hmm.
you know?
Yeah.
So
Yeah. Good. Sorry, I didn't mean to
no,
cut
no,
you
that's
earlier.
all. Yeah.
That was it. Okay. Yeah. And the only reason why I bring that up is because, you know, there's some of my hypotheses. If I sort of bring you up to speed, how I'm thinking about this is, I think there might be a sort of case to be made where the auto market might resemble more of, say, like the phone market nowadays, the smartphone market, where you
Yeah.
have two major players in, say, Samsung and Apple, and then or say Android and Apple, and you know Samsung's really the biggest player, but it's one automaker or one cell phone maker is making the majority of profits and might still have, you know, 15-20% of market share globally, maybe 50% or 40% in the States, but they're kind of hoarding a lot of the profits because of a lot of the bets they made early on around the manufacturing, the supply chain, sort of how they want to package the product. And so I'm just curious to see if really there is an analogy between if there's some parallels between how the auto market's going to sort of transform into the next 5 to 10 years as it becomes more and more digital versus where we were before. And if the first mover in this case, let's say a Tesla, has an advantage ahead of time with their scaling and what they offer, that they could have an outsized sort of success in that market. Given that, at least from my perspective, you're a lot closer to this. I'm not seeing nearly as much advancement from some of the traditional players as I would have hoped by now. They still seems like it's a lot of the same, but maybe I'm wrong. And that's the only reason why I asked that question. Yeah.
It's a really great question. And it comes up all the time. So in the future, we'll have software-defined vehicles where the vehicle will be defined by the software. Now, why do people love Apple and why do people love Samsung? It's typically they're addicted to either the iOS or the Android operating system. Like, I could not imagine losing my 9 years of iCloud photo storage.
Oh, yeah.
I use it every day. I travel with Sandy, and if I want to find a photo, I can find it instantly, because every time I take a picture of Sandy or a video, which I have more pictures and videos of Sandy than my kids and family combined, I literally click on the map, and I click on the map of all my photos, and I'll zoom into Italy right to where Idra was, and I'll say, oh yeah, here's all my pictures at Idra. Or when we've traveled to Norway, I zoom into Norway. Like, how I use the software, I cannot imagine switching to an Android phone. And I don't want this whole thing to be like, oh, Android versus Apple, but it's a software defined love. Like, I am addicted to the user interface, the iOS. The phone, this is just like a vessel. It's like the body. I look at it like your mind. Imagine if you could upgrade your body every 4 years to a brand new 25-year-old yourself. You do it. I look at the phone as, well, I'm just upgrading the body and the mind, all of the synapses and everything I'm connected to, my apps. So you got to look at Tesla. They're creating software-defined vehicles, which you get really addicted to all the user interface, the FSD. Imagine switching where now you have to go to a dealership to get your car updated. And my wife drives a Kia Carnival. We've never had new vehicles. She drove a used Mercedes, and I did all the maintenance and never went to the dealer. And I drove a used Yukon. We finally buy her a $50,000 Kia minivan. I'm like, you got to take it to the dealer to get the oil changed because it's under warranty and whatever. And she goes there, and they're like, oh, we have to update your car. And she just had a third child. She's breastfeeding. She goes to the dealer. She thinks it's going to be 45 minutes. It's been like 2.5 hours. She's like, I got to get out of here. And they had to cancel it. So she's tried 4 or 5 different occasions to get the update done. And it's failed every time, or it took way longer. And she's like, I hate my new vehicle because of this stupid dealer and the update. And there was 2 recalls for like a door and this and that. And she's like, oh my God, this is horrible. And I said, well, if you had a Tesla, they'd just come to you and the updates would be over the air. And she's like, so her user experience is bad. She loves the vehicle. It's huge. I have 3 kids and a dog and whatever. And we got it because, they make nice products, but if there was an electric van, I would have it, but I don't.
Yeah.
So I guess my point is, the value is in the user experience and the software-defined nature of the product, because people will upgrade the vessel and they'll continue to stick. Just like Apple is like a religion, and Tesla is like the same religion, and Elon is the god of that religion. Just like Steve Jobs and now Tim Cook, they're like deities in Silicon Valley. And I don't want to draw parallels to actual deities, but it's important to have that type of leadership where it actually trickles down, where people are that passionate, where they'll stick with the products based on their user experience. And I think Tesla and companies like Apple are highly focused on user experience and continue to improve that user experience, and that trumps everything. And
so you think that in the coming years and decades, if a car makers should very much keep that in mind when they're thinking about developing their next generation platforms. Is really focused around the software of the vehicle, and I guess the self-driving and its ability to drive itself is also going to be paramount in that experience as well. Is that how you're thinking about it?
Yeah. And the way traditional vehicles were developed, there was a lot of roadblocks to having complete control. So if you look at the number of ECUs in like an internal combustion engine vehicle, you'd be looking at 50, 60, 70, 80 little control modules. So you have control modules for your airbag system. You have control modules for your lift gate. You have control modules for your sunroof. You didn't have a centralized computer that would run everything. So, and oftentimes you'd work with a supplier that they'd lock that feature onto that hardware and encrypt it. And you'd only be able to talk to it in some like very basic way. And your liftgate feature, whether that's like as it goes up and it stops and, senses and all sorts of stuff, the supplier would actually want to control that because they control the cost of that module and the feature. And it really puts you in a box because once you build the car with all these fragmented boxes and features, your ability to then make updates and improve that over time was essentially not even
Gone.
possible.
Yeah.
So some OEMs are now trying to get their suppliers to provide them with hardware and ECUs that allows for updating, but it gets even harder. Tesla has essentially said they're taking control of, I think, 80 or 90% of their ECUs on the Cybertruck and then 100% on their new compact car. If you have complete control, like imagine Apple not having control over some of the chips in here for like the camera or the speaker, and you could update your phone, but you could never update the driver for the camera. Like that would be like, that'd be like wild. No, Apple has the ability to make updates to all the features of their phone in case there's a problem. And I think Tesla is the furthest along in that. And other OEMs, to answer your question, you have to change how the purchasing organization interfaces with suppliers and engineering interfaces with suppliers. It's a much higher level type of decision. And Sandy and I have talked with a lot of experts in this field. This one guy is amazing. His name is Thomas Mueller. He works at a company called Wipro, WIPRO. When he talks for like 2 hours, I just listen to him. And that's where I got a lot of this information. Thank you, Thomas. He talks about software-defined vehicles, and he is like brilliant. And we do some collaboration with this company, just very little. We're looking at our Hyundai Ioniq, and they're kind of taking a look at it to see if we can pull some information from that. But it's quite incredible what's possible if you have a vehicle that emulates a cell phone.
That's really interesting to hear. So it's the steps a company can take sort of to, would you call that vertically integrate their, is that vertical integration basically how you're thinking about it, or is more like creating good relationships with suppliers? Like how do you think about that?
I think the vertical integration doesn't apply as well when you're talking to, the software aspect of it. Vertical integration more appropriately applies to like whether you build your own seats or your instrument panel or your thermal system. Do you build your doors in the plant? Do you paint your fascias in Germany, or do you ship in your fascias painted? Like vertical integration, I think, is more towards like the physical parts and stuff.
Manufacturing of it. Yeah.
And this is more strategic planning, long-term strategic planning. And it's like critical thinking. And oftentimes you'll have large organizations that are focused on their annual performance, their quarterly performance. This is like looking decades out. And Sandy tells this story about when he went to Japan when he worked for Ford, and the Ford team or the Toyota team mentioned that they year plan. They had 100-year plan. This was in the 70s or 80s. And one of the executives he was with, or the VPs, laughed. And then the Japanese people said something under their breath, and Sandy talked to a translator, and the translator essentially said that the Japanese people thought it was foolish that the contingent from Ford was thinking so close, whether that's 3 years, 5 years, 10 years, 20 years. And I thought it was interesting that an organization could have a 100-year plan. And I feel like Tesla is more of an organization that has that 30 to 50-year vision, because his vision, Elon's, is essentially speeding up the transition to clean energy, renewable energy in the automobile industry and other industries as well.
Yeah, it's fascinating to bring that up, and then I want to deep dive Cybertruck here because we're already over an hour, and I feel like we've just started because you've just shared so much incredible information. Thank you for your time. Seriously, This is like, it's mind blowing every time I talk to you. The latest strategy from Tesla that has become quite clear is we are going to try, and I always bring up Tesla because it's just such a fascinating sort of part of this whole auto industry and how it's evolving, because it's sort of, again, like hitting these things that we've all taken for granted is how a car company should behave, but they've sort of breaking the mold. They've openly said, it's like, well, we're going to drop the price as much as we need to get as many cars out of the factory as possible. Yeah, we might not make any money doing it, but we think that's the right thing to do long term, because that means more cars on the road. They're going to be able to drive themselves. And this is the first time that you can actually sell a car that's going to be able to make money in the long term versus it depreciating and then you can't make any revenue off of it. Does that sort of resonate with you as it pertains to like that long-term strategic thinking? Would you pile that into the same bucket? How do you think about that?
Yeah, and I hate to beat the old Apple drum again, but someone asked me what was my first Apple product, and it was when I was 18 or 19. I bought one of those tiny little clip-on Apple Nanos.
I remember those.
And because I ran a lot, right? And I was an intern working at Munro, and I was making $15 an hour, and I was paying my own rent, and I had my own car. I didn't have any money. But what it did was I had to download at the time iTunes, right? iTunes days. And it was a little green Apple Nano thing. And I could put like, I don't know, it was like 250 songs or like 1,000 songs. And I was blown away. And it worked so well. And the quality of it was aluminum and it was machined. I think I still have it. And I used that thing to death. And I got all my stuff into iTunes and whatever. And it made me really want another Apple product. So my second Apple product was actually an original iPad, first iPad that came out. And I got it with cellular data. And it was like a 64 gigabyte. And it was like $1,000 or $800. And I bought that thing. And I still had like a flip phone and I had an iPad. And I thought it was so cool. I took it with me. And then I got an iPhone 4. And the rest is history. So if you want, and I think my friend Ross asked me that actually. And it's like, did Apple make any money off that Nano? I don't think they did. That thing was like cheap and it looked rather expensive to make. So if you start someone in a Tesla, what's the likelihood that they abandon it? It's probably low, right? So loyalty is strong. So if Tesla spent a whole year selling vehicles at break even or even at a loss, they would sell way more. If they literally dropped the price to exactly what it costs, they'd essentially be kind of like Amazon, because Amazon reinvests all their cash every year into buying more planes, building more warehouses to get their revenue up. So as a business, you want to focus on two things. You want to focus on profit, but you also want to focus on revenue growth. And as long as that equals 30% combined, you're doing well. So if you have 30% growth and zero EBITDA, it's actually not bad because it shows you reinvested to get the growth. But if you have 30% EBITDA and you're flat, that's actually concerning. It says you're not investing enough. So because I'm the president of a small organization, I have to tell Sandy, I said, sometimes we reinvest our cash into doing these teardowns, and they're expensive. We buy these cars, we tear them down, we write these reports, and we don't see the payback for almost a year or two. And maybe it hurts our short-term profitability for that year. But I tell Sandy, I said, look how much street cred we have now that we tore down a Hyundai Ioniq and a Ford and a Rivian. We actually have the context to sit here, and it's not bull crap, because I actually have like 10 EVs torn down like 50 feet from me outside the store. Yeah. And Sandy and I fly all around the world. We've been in like a half dozen or a dozen plants. We met all these amazing people. And so when you look at an organization like Tesla, cutting the prices to move metal is a good strategy if it's a long-term strategy and your growth is there. If you have flat growth, if you're not growing and you're cutting prices, that's red flag.
That's a problem.
So if the growth stays there, and if the growth actually accelerates from your price cuts, then you're in a really good position.
Do you think legacy automakers should be at all concerned with this move, given that Tesla is now in the millions of units per year? Like, how do you think this will impact legacy automakers whatsoever? Is it going to eat into their market share, or do we have to wait and see what happens? Do you think about that at all?
Yeah, I think something that needs to be considered is Tesla is still in very few segments. They make a relatively small car, the Model 3. The Model S is a large car. The Model X is kind of a crossover, large, and the Model Y is kind of in between, crossover size. They don't make a true SUV. Like, I think of an SUV, I think of a Jeep Grand Cherokee or a Toyota, like a Sequoia or a 4Runner, something with, beefy sidewall tires, large aspect ratio, can kind of take it off-roading. A
big boy.
And that's, let's not kid ourselves. A Model Y is essentially a bloated aerodynamic car. It's a CUV crossover. It's not really an SUV. And if people say it's an SUV in the comments, it's not really a sport utility vehicle, which would be derived from like Land Rovers or Jeeps or a Toyota Land Cruiser. To me, the ultimate SUV is a Toyota Land Cruiser. Like, that's a sweet SUV. And anyways, so they're not in enough segments to totally dominate global market share. You can't go buy a 3-row SUV right now, traditional SUV. You can't buy a truck right now. The Cybetruck comes out this year, maybe
next quarter, according to them.
Yeah, maybe 5,000 to 20,000 this year if they're lucky. But then that's only one truck. That's not a heavy duty truck. That's not a small truck. That's not a, so in order for Tesla to truly put on their mitts and fight these OEMs, they need to enter essentially a dozen segments: the super compact A, the B, C, D, SUVs, small, medium, large. I think there's like 5 different sizes of Jeeps. If you count the Compass, the Renegade, the Cherokee, the Grand Cherokee, the Grand Wagoneer, and then the Grand Wagoneer, the long one. And then you have the Grand Cherokee L and the short Grand Cherokee. They got all that complexity. So Jeep alone has like 7 Jeeps, and they all sell pretty well. Stellantis does not do bad. They sell tons and tons of Jeeps. So Tesla doesn't have one direct competitor to any of those Jeeps. They just don't. So I know this is a super pro Tesla channel, but they make amazing products in the segments they're in. They're just not in the dozen or so core segments globally.
Sure. No, that's great context. Let's get into the Cybertruck now, because I think that's when we saw the one picture out of Tesla posted their earnings report last week. There was a picture that you posted on Twitter. Go ahead and pull that up, producer wife. The picture of the Cybertruck that we teased earlier in the stream. I want to get Cory's thoughts here, and then as we approach the end, we'll do like a 10-15 minute Q&A if you're cool with that, Cory. Like towards the last 15 or so of of the stream. So this is from Cory's Twitter account. Do follow him at Cory Steuben. You see it right there on the screen. My brain is literally on fire, poring over this image, zooming in and studying every detail. Can't wait until we get ours and bring it to the world on live Munro. Headed to Berlin to tour Big Factory on Friday, which we talked about briefly at the beginning of the video. Go ahead and click on that image, producer wife, and then let's Cory. Why is your brain on fire, my friend?
So it's the size. So if you look at the Giga casting on the front of the Model Y is very, very big, and the length of this going from the hinge pillar. So the hinge pillar is what you see, the white on the right. That's where the hinges for the doors connect. That's why they call it a hinge pillar. The length of this is tremendous, and they're using a very similar strategy that the Model Y uses. Towards the front, all the way to the left, you'll see a small aluminum weldment that attaches. It's called a fender bracket. So in this photo, you see one part, the massive casting, and then you see that the fender bracket, which is 1, 2, 3, 4 stampings. So on the other side, there'll be the same 4 stampings. So you'll have 9 parts create the whole front structure of the vehicle. Now think of the Rivian. We have a Rivian. It's body on frame. So there's a whole frame rail and there's a whole complex. You're talking hundreds and hundreds of parts with probably 500 to 1,000 fastening points between spot welds and threaded fasteners, and probably kilometers of structural adhesive. Just the sheer fact that the whole front of the vehicle, I only see 5 parts, and you can imply that the bracket's the same on the other side. And then I can see a tiny little portion of the crush can sticking out, but no front bumper beam. And then I also see the high voltage wire laying down. It's that orange wire that's kind of coming out from the lower portion of the toe board
there. Yep.
And that's what's going to go and power your front drive unit. It's a very reminiscent of the design philosophy and build philosophy of the Model Y out of Texas. So it's the Giga Texas version of the Model Y. Now we're going to assume that the battery is a structural battery pack with 4680s. So if you just do some parametric math, so the tonnage on this Giga press is 9,000 tons. That's what Idra says. That's what Tesla says. They're currently using 6,000 tons on the front Giga casting. So I'm guessing they squeezed as much aluminum in this as possible. So you're looking at a casting that's a third larger. And when you're designing a vehicle like a truck, profit margins on trucks historically have been huge, because when you're using 33% more material, that's like the smallest amount. That's a very small driver in cost compared to the size of the vehicle. So people will pay $80,000 for like a F-150 Limited or a Silverado, whatever, but the amount of material is only like 25% more if you count steel and aluminum. So you only have a small parametric growth in material usage. So the suspension parts get slightly larger. The Giga castings get a third larger. The steel is larger. And the only real wild card is any manufacturing problems they have with the unique exterior. So this is not an exoskeleton. So everyone's like, oh, exoskeleton. If this was an exoskeleton, you would not see this traditional build style. So this is like a model. This is like a big old Model Y, huge casting in the front, huge castings in the rear. It's not a body on frame. It's body on white. And if our viewers out there don't know what that means, body on frame is you have a ladder frame and then you put the body on top like a truck. And the way those are designed and the NVH characteristics are wildly different from a stiff singular body. So this will be more like a Honda Ridgeline, I know, and less like a F-150, but this thing is huge. And so the reason why I said my mind's on fire is because I can also see the fastening strategy just below the windshield of those tiny little circles. I look
Mhm.
for if they're slotted to see how they're going to align and secure that outer stainless steel. I can see multiple witness marks for threaded fasteners in the hinge pillar, and that's exactly how the assembly of the Model Y body side outer and body side inner, which make up the hinge pillar, and then the rest of the body side are secured to the front casting. So I know I'm just kind of riffing here. I can also see a low voltage harness hanging down. It's the black harness,
On the
and
front.
you can make out a little bit of the size of the connectors, but those are going to be going to most likely everything in the cooling pack because it looks like they're hanging down to the left, but they're relatively large. So there's what's amazing to me is this is an evolution of the design philosophy of Tesla applied to a truck.
Mm.
You know, it'd be like if you took the Model Y from Texas and say, let's make this thing a truck. Okay, let's stretch it. Let's make the casting bigger in the front. Let's make it shaped like a weird triangle. Okay. And the only real wild card, like I said, is how you're attaching those large, thick stainless steel, most likely brake bent. They're bent on like big brakes, not stamped. If there's any challenges, I think that's where the challenges will lie because stamping hoods, fenders, body side outers is like really well refined. That's how Toyota makes cars, Kia, Hyundai, Ford, everybody. That's how Tesla makes cars. I stood in the stamping shop in Berlin and watched the panels come flying out. And I saw all the storage of the body side outers and inners and trunks and hoods and doors. This will be a huge departure with all these really hard, thick, straight stainless steel pieces. Um, and we'll have to see if there's fit and finish and quality issues in their early builds, because that's my biggest concern for the Cybertruck.
Got it. So let me go ahead and pull up a picture of body on frame, so folks that are watching this can understand sort of what Cory mentioned. Go ahead and pull up the picture, producer wife. So this is body on frame, right? So that you have a big old frame, and then you put the body on it. Literally, that's how pickup trucks are built today, right? Traditional
Yep.
pickup trucks.
Yep.
And so if we pull up the second to last link I sent your producer wife, which is the earnings report that Tesla showed, and then go to page 13, which is sort of the big picture that the bigger picture that Cory showed us, or that we had pulled up earlier. Go ahead and pull that up, yeah, and just zoom in on that picture of the Cybertruck pilot line right there. Yeah, go ahead and zoom in. And so this is like so that the Cybertruck is mostly in it, and so it's kind of hard to tell from this picture, I guess, but it doesn't have that sort of those two steel or whatever they are, line or things that you want to call. It's more like you described, like a big Model Y with a huge bed. And so where's this? What's the exoskeleton then? Is that just did they scrap that idea? Like, help us understand a little.
Now,
Yeah.
so an exoskeleton would be a complete departure of how a vehicle was developed. And this is what you're looking at right here is all the underpinnings of a traditional body in white, but instead of complex weldments making up the front of the car, it's one casting. And in the rear, it's yet to be seen how many castings, but they've implied that there'd be multiple castings. But those castings are built in a way to have all the mounting provisions for most likely the door, for the bed, and any sort of features they have. And the castings do engage much higher than on the Model uh, Y. And if this was truly an exoskeleton, you wouldn't need all that internal structure. It's like if you're an exoskeleton, you don't have bones on the inside. Think of it, if you're a lobster lobster or crab, the outside is the structure and the inside is all the muscles and stuff. So I think the exoskeleton was a little overplayed, because if it truly was an exoskeleton, that's where all the structure would be. You wouldn't need so much of the strength, because those the white part, what you see. So if you look at the side of the car, you have the stuff that's gray, but the white portion, you're probably looking at ultra high strength steel for structure. And ultra high strength steel is boron steel that's typically hot formed. And if you were truly relying on the stainless steel exoskeleton, you would need no boron steel. I bet dollars to donuts that when we get that and we tear it down, they have ultra high strength steel, because of the strict requirements for safety. You need it for the structural rigidity for all the different crash tests and whatnot.
Got it. And so are they going to still, do you still predict them to use the same sort of material for the actual body of the vehicle, for the doors and the hood and everything? Is that going to, not having an exoskeleton, is that going to potentially put that at jeopardy?
Well, no. So all the closures, so the doors, the hood, those are their own separate structural entities, and they are already like that in a vehicle. So if you have a door, you can take the door off and the door won't like fall apart. You don't need, the vehicle doesn't need the door for the door to stay in its shape. So those will be their own structural elements.
Gotcha.
You'll have an outer and an inner, and they'll be welded together or bonded together. And there's all sorts of ways you can manufacture a door: composite inner, aluminum outer, stainless steel outer. So I don't want to get into door construction or hood construction, but and most likely the fender will not be contributing to structure. So I saw that fender bracket. So if you look at the fender bracket alone, it's this flimsy aluminum piece. The reason
Is it on this one or the other one?
Yeah, actually you zoom into the front. Yep. Zoom in. Yep. And go to the left a little. The other way.
Yeah,
there you go. That fender bracket is very flimsy. It's not super strong, and that will interface with the front portion of the fender. And the reason it's not super strong is when you're fitting and finishing the hood to the fender and the fender to the wheel, there needs to be lots of play. And if the front fender was truly structural, you would need to have a super strong tie-in to the casting, like a really thick, strong tie-in, not a little flimsy aluminum fender bracket. So that right there implies that the fender will not be contributing in any meaningful way to the structure of the vehicle. And if you look at a picture of a Cybetruck, with the sides on, the fender is a large portion of the vehicle. So I'm just, I hope I'm not like sounding like I'm just stating the obvious. There's like a big old Model Y in the core underpinnings of it from Texas. Yeah.
That's helpful. And you mentioned, so this style of manufacturing for a pickup truck, has any other manufacturer done a pickup truck in this form where they kind of blow up sort of a SUV form, I guess?
Oh yeah.
Has that done before? Okay.
The Ranger, the Ridgeline. If you look at any pickup truck that is a non-body on frame, it's essentially a Honda Ridgeline is a Honda Pilot that is stretched and shaped into a small truck. Have they done it to this scale? I don't think so. I don't think anybody's ever taken it and said, let's make it the size of a full-size truck. They always take it and make it the size of a slightly larger than a 3-passenger SUV.
Okay.
Or
what are some
3-row SUV? Sorry.
No, you're fine. What are some of the like surface level, without, you obviously haven't seen it torn down, you haven't really spent any time, but conceptually speaking, are there any pros and cons versus, say, a traditional body on frame pickup truck using those methodologies? Like what's the, cost benefit analysis there? Like, is there something there that we can throw around?
So body on frame, you typically have advantage if you're towing 20,000 pounds, 30,000 pounds, because you have this massive, thick steel ladder frame that's sitting over typically solid axles.
Mm.
So if I were to have horses and tow them, I would buy a 3,500 truck, a diesel with a giant dually rear axle and a big diesel engine, because I'm going to have a gooseneck that's going to go in the bed, and it's going to distribute the weight on that uh, on the fifth wheel onto the frame right over the axles, and it's just like massive thick steel. And not only is it thick steel, it's hydroformed. It used to be C channels, like just C channel steel. Then they made box frame. Then they became high strength steel. Then they became hydroformed. They've been improving year over year over year. And if you look at a modern truck, it's like amazing how much they can tow. It's like 30 or 40,000
Yeah, it's
pounds.
crazy.
So will a Cybetruck be able to pull up next to a 3,500 and handle a gooseneck trailer the same way? Maybe, but probably not to the same extent, because it's going to have independent rear suspension, air suspension, which has a lot of benefits for ride and comfort and handling and off-roading and all whatever. But if you want to tow, look at a semi. They have solid rear axles. They're very flat and heavy and stable for hauling down the interstate. So like semi trucks are, ladder frame. And like, look at the Tesla Semi. It's a giant ladder frame with huge solid axles. If the Tesla Semi was a unibody, that would be wild and weird, and I don't even know how it'd work. It doesn't even make any sense.
Yeah.
So it's like the right design for the intended purpose. So could other OEMs have a unibody truck that's the size of their F-150 and whatever? They could. I think other OEMs tried it in the past. I think in the 60s or 70s, I think Ford had a unibody truck for a while, but I don't know. That's all I have to say on unibody versus body on frame.
Okay. No, I appreciate that. Cool. I can't wait for you guys to get yours and tear it down. There's so many questions that need to be answered. That's crazy. Let's go ahead and I know we only have a few more minutes left here on the podcast, and I want to make sure we do give a couple questions to the audience. Thank you so much, man, Cory. You're so. I always tell you guys, like, I can't believe all your stuff is free on your channel. It's unbelievable. But I really do appreciate the time you guys take to really educate us and really get us up to speed. Let's go ahead and bring up a couple questions, producer wife, when you get a chance. It does sound like to me, for the Cybertruck, I am really curious to kind of, once you guys get that car and really break it down, I'm just the biggest thing I'm curious to learn is sort of how, one of the things that Tesla said is like, hey, we're going to be able to really get this manufacturing process down to a point where the cost of manufacturing a pickup truck is going to be quite similar to a car or an SUV. And I'm very curious to see if this sort of methodology they've used is actually going to get them there. So I really can't wait for y'all to break it down to see if that actually hits. They have a pretty good track record, but I'm actually very, very interested to see if that is one of your biggest learnings. All right, let's go ahead and pull up a question, and we'll see how many we can take in the next 5 minutes or so. From Nick Carter, let's ask Cory about Highland. So the Model 3 Highland program, do you have any information on that? Have you seen any pictures? Do you have any estimations?
I saw the supposed leak photo where somebody pulled a cover back and it had the headlights that kind of look like the Roadster headlights.
Roadster, yeah.
I'm guessing that the Model 3 will finally have some Giga castings in it, because when we interviewed Sandy interviewed Elon, I was there back in 2021. Sandy asked him, like, hey, are you going to put some Giga castings in the Model 3? And he said, no, we've already set the line up. We're already making it mixed material body. We received a Model 3. No, we already had it, and we were disappointed it didn't have the castings. So I think the Project Highland Model 3 will start to deploy Giga castings in the rear, not the front. And I believe it'll have the fourth generation drive unit. So all the costs realized from that. I think it'll have an internal and external refresh, and it'll be that internal and external refresh will come 2 to 3 years before a similar internal and external refresh for the Model Y. And I think Project Highland will reinvigorate Model 3 sales, because if it looks fresh and new and the interior, maybe the screen gets bigger, they make the interior slightly more Model S-like with, increased features or a better screen or whatever. That's my best guess, is because it's been, 6 years since the Model 3 launched?
Years.
So it's time for a refresh. You can't make the same car for a decade. You just can't.
Mm-hmm.
And the Model S went through different refreshes over time. I mean, look at the original ones with that huge grill, and now they look so much better, in my opinion.
I agree. All right, let's do the next question. And Jake, wish Cory would do a teardown of BYD's cheaper vehicles. Is that on your roadmap?
We've considered a few BYDs and some Neos and some Xiaopangs, Xpeng if you're from the US, and it's on our radar. So it's just very expensive and hard to get the vehicles in the US.
Okay. Let's maybe we should start a GoFundMe for y'all to get it. All right, let's do another couple more. You got 3 more minutes?
I got like 2 more minutes. 2 more minutes.
Okay, so we'll make this the last question then. From ts.la, current Model Y's 4680s have far less range with the 2170s. Want the Cybertruck need 4680s with a new cam to surpass the 2170 efficiency? Are they currently working on new cam or only DB dry battery electric ramp?
So from my visit to the Texas factory on Investor Day, they didn't mention anything about the chemistry, and a few people asked about whether or not the 4680s could be made with LFP or they're going to stick to the current chemistry. They did not bring up chemistry at all. So that's all the intel I had from that tour. And you are correct, 4680s do have a lower volumetric and gravimetric energy density than the 2170s. So it is possible that early Cybertrucks do have 2170s.
Got it. Okay. All right, Cory, we'll let you go. You got a lot going on. Thank you so much for making the time, man. Really appreciate you. I know you just came back from a trip in Berlin as well. Any parting words before we'll let you go, get back to work?
Nope. Thank you. Always a pleasure being on your channel.
Of course, man. Yeah, you're welcome back anytime. Cory Steuben on Twitter. Make sure you go check out Munro Live podcast on YouTube as well. YouTube just launched first podcast today. Thank you, Cory.
Yeah,
we'll see you around, brother. All right. Bye, everybody.
Hey.
Take it easy.
All right. Hey, I just got to pee really bad. See you.
Nope.